Okay, meanwhile, so please wait. Okay, we'll start maybe at 3:35 today, but from tomorrow sharp we'll start by 3 o'clock sharp. Okay. I have not yet started. I have not yet started. Don't worry. Hope my voice is audible as of now. Oh, recording started. So then we can start now sharply by 3 o'clock now. Fine. So we'll continue. In this session, we'll continue about understanding the data. Okay. So what actually understanding the data means, data speaks a lot. Okay. For me, in this field of data analysis and as a statistician, I have seen a lot. I have seen a lot of practical data sets from my post graduation to till date. I have worked with several practical data sets, and I have worked with doctors as well, where data has its own what we say own importance of telling something. Okay. Okay, we'll answer the questions later. We'll answer the questions later. Okay. Well, let us start the discussion now. I'm trying to share my screen now. Fine. So we start with this. Start with this, that why we need to understand the data before going to any applying any sort of advanced statistical techniques. Why we have to understand the data. So with my practice of around let us say 15 years in as a statistician, from my post graduation days to till date, what I have understood is the best way to understand the data is to visualize the data. Okay. Once we visualize the data, we will come to know many intricacies of the total data, which what we have at hand or what we have collected. Maybe it is a primary source or the secondary source. First, we have to understand the data based on the graphical visualization. Okay. Now, as per now confining to this discussion to the R, what sort of a statistical learning do we need to have in order to tackle the data? Okay, data is very precise. Data is very important because it tells us, it will support you to meet your objectives at the end of the reporting. So what sort of structures, what sort of architecture we need to have once we start understanding the data? So with this, I'll start with, with this hexagonal architecture. So the statistical learning in R basically requires 6 steps to go. Okay, what are the 6 steps to go? The one is arranging the data. Arrange, read, check, select, interpret, and present. Okay, so these things are very pivotal elements of statistical learning pertaining to R, but in general, you can have in every software. Arrange means a proper arrangement of data, structuring the data according to the software requirement. In R, what we do is, if it is a categorical variable, if it is a continuous variable, that is interval ratio. I will come to that part later. Okay, whatever the type of the variable, basing on that, no need of a class label definition, but still we can have the string variables, character variables, we can have numeric variables all together at a hand and then start functioning with them. But whereas when you come to SPSS, all the character variables, that is string formats like male, female, area, urban, rural, semi-urban, you are deceased or non-deceased, all the such kind of information should be categorized first. So purely the arrangement of data vary from software to software. Okay, so most of time, but it is a best practice for every data practitioner, not only the statistician. I mean to say that for every data practitioner, it is the best practice to have a code sheet in your with you all the time, even after the completion of report writing and presenting the results also. What do you mean by code sheet? Code sheet contains the total variables what you have in the data set, and then what each variable stand for. Suppose if I take age, it is a continuous variable, and units of measurement, or how you speak about age, is in years, in months. If you are collecting the data in terms of month, pertaining to neonatal, it will become in days. Okay, so basing on the study design, study objective, the measurements should be given. Let us take weight. Weight is a continuous characteristic in kilograms or in grams, basing on that. Okay, generally this code sheet should contain, suppose you have gender variable, 1 is a code for male, 2 is a code for female. Likewise, for every variable, that code sheet should be prepared, and it should be forever with you even after conducting the analysis and report writing is also done, is also over. Whereas coming to R, that kind of a code sheet preparation is required, but the codings are little different. Okay, different in the sense that if you have a male female, directly you can figure out male female as a text rather than the code what you have practiced in other formats of SPSS. Okay, so arranging the data is nothing but properly bringing into one particular shape. Okay, now reading the data. Reading the data means how you bring the data into our environment. Okay, what set of a supporting files that R will give you. Okay, you have data in Excel format. Okay, read.xls is the function to bring, to import the data from your local library to the R environment. You have stored your data in CSV, comma separated value file, read.csv. You have stored the data in text format, read.text, read.dat, read.table. All different. You can import SPSS file, read.spss, read.sas. So SAS format, Excel format, CSV format, different formats of data where you have stored, that can be brought into R environment. That is the next step what you have to do in R. The next thing is check. Check means whether the properly, once the data is loaded into our environment, observe the characteristics of the data using certain function called, certain functions using available in R. Okay, so this check option will tell us how many numerical variables are there, how many string type variables are there, how many character type variables are there, how many date formats are available. Once these three steps, these are all very preliminary steps that one has to follow. The next important, very paramount importance is the selection of statistical tests. That purely depends upon the nature of the data. Okay, is it a nominal type, ordinal type? So in the total statistical analysis world, the choice of statistical test purely depends upon the nature of the data. For example, let us take the teaching mode what we are exercising now. Earlier, we used to have a physical workshops. Now we are having e-learning workshops. Okay. Now the knowledge gained through different modes of understanding, if you take, okay, the IQ level, the IQ level observed through two different teaching methods, then There I am calculating IQ level, which is a continuous variable, but I have a two groups. One is oriented with a physical nature, which is a traditional one. The other group is trained, the same content is trained with a e-learning, that is a virtual learning kind of a mode. How far the knowledge grasping is being made to the audience with the two different modes of teaching, that is physical teaching and conventional traditional teaching, and e-learning, virtual training. Okay, now I have two groups and I want to see which group benefited more or less the same, or which has a least amount of concentration or learning, the grasping the content. So this becomes a two group comparison kind of a thing. So before you start the study, you will be knowing what you are trying to show in the study. So those objectives, according to those objectives, you will be filtering, you will be scribbling the variables that are to be required for data collection. So the choice of statistical test purely depend upon the objectives, and these objectives will be dealt by making use of certain variables which are already collected. Now the other one is interpretation. Once the outputs are done using some coding or some kind of already available built-in functions, this is very crucial and very important. Okay, you should be able to interpret the outcome, and it should reach to the domain expert to the maximum extent. Especially what practice I do and what practice I convey to all of you, because in this audience there are different varying age groups are also available, who are already working with data, who are learning how to handle the data, and who are good at some extent they are also good comfortable with handling the data. So the best practice to do in this portion, interpretation and presentation, how to present the result, these two aspects should be done in hand with the domain expert. If you are working with a psychology person, you have to sit with them, start discussing the results. Then that discussion will make you to elaborately describe what you have noticed, what observations you have made in the data, and out of it, what you're trying to present in a beautiful table forms, graphical forms, model, what next, whatever may be the thing. So this 6 steps in any software is quite important, that has to be followed. Okay. So with this, we'll start to have a small recollection of types of data. That is generally the broad classification comes with categorical, or sometimes we call it as a qualitative variable. The other classification is numerical or quantitative variable. Okay, so here we go under qualitative, you have two subcategories, that is called nominal data and ordinal data. Coming to the quantitative, you have discrete data, which is called also called as count data. Okay, and then which is called as continuous data. Okay, in most of them, this continuous data again has interval bar ratio, but in general sense, I claim that it is a continuous data. Okay, right. Now coming to nominal data, what are the nominal data which doesn't have a priority, like gender, region? These are all called comes under the category of yes or no. Do you have now you have Argosy app? Most of the data what you have given is a nominal data. First it will ask, do you have cough? You will say yes or no. Okay. Then you will have another question. Have you been outside for 28 days? You say none. Okay, then are you having any other symptoms like cardiac arrest or hypertension or any other thing? You say none. Okay, all these things assessment, you will give a final answer. You are safe. You are in danger. You are moderately risky. So what I mean to say is, I want to tell you with this kind of a questions, we can understand both nominal data and ordinal data. Nominal data are those which doesn't have any order of priority. Yes or no? Yes, I have a pain. I got hit to the head, my head, and I have a pain. Yes or no? I have a headache. I have a vomiting sensation. All these clinical symptoms relates to nominal data. Now, the final outcome of Arogya Setu app will tell that you are partially risky, you are safe, you are highly, your risk is high level. So this safe, moderate, high level of risk corresponds to the priority there. because you take a decision on such kind of a phenomenon. If you are safe, yes, I am safe, I should be very careful hereafter. If you are moderately risk, immediately you have to take a medical attention. If you are at high risk, definitely you have to go with proper diagnosis or proper directions of the medical staff. So the ordinal data has some priority of further action in the data. So similarly, the severity of pain. Okay, your score grading systems, A plus A, B, B plus C, failure, all these things comes under these qualitative phenomena with the branch of nominal and ordinal data. Coming to discrete data, now whatever the COVID counts we have, how many got infected in Tamil Nadu? In each district, how many we are asking? Okay, how many are totally infected? How many are recovered? How many are still inactive? How many deaths? Okay, now how many people get infected because of these symptoms? What is the probability? What is the most likelihoodness that if these symptoms are available, then what is the how many people might get affected? You are estimating the count there. Okay, now that is what we call discrete data. Okay, or I can take the class interval of school, I mean class, that how many students have secured A plus grade, how many students have secured A minus, B plus failures, absent to the examination. All these things correspond to discrete data. Now coming to the continuous data, which are in certain standard units of measurements like weight, temperature, speed, velocity, all these things can be measured. From these certain continuous type of information, there will be some more measurements called derived quantities. What are those derived quantities? Simple example is BMI. The BMI quantity is obtained by calculating weight and height. Similarly, waist hip ratio, using waist circumference and hip circumference. Like this, in total, we will be having these quantitative variables will be with the combination of some derived quantities, some actual information procured from the any kind of a phenomena what we see. Okay, now I recollect, I admire Professor C.R. Rao, who is celebrating his 100th year. This September 10th, he will be completing 100th year. We should owe to him for bringing lot many statistical methods into the scientific field of science and technology and engineering. Okay, so in 1979, he has a lot of vision, and he what are the perspectives in statistics. Okay, now he says that statistical research can flourish only in the atmosphere where the statistical methodology should be useful in solving problems in other disciplines. Okay, so that's what he says is, no doubt a statistician should be equipped with the practical skills to enable him to choose appropriate methodology for analysis of given data. So what we are trying to claim here is statisticians should not also be should not be alone trained with strong theoretical structures. Okay, you have trained him in getting the covariance structures of a multivariate ANOVA. You have trained him how to make the root mean squarer of a regression model. You have trained him how to calculate R square. You have trained him how to compute ANOVA. I mean, how to understand, derive the expressions of all these things, but not that is required. The practical essence of each technique. What is the technique stands for, why it is to be used, and when it is to be used. So this question-based learning will tell the essentialities of each theory behind its implementation to the data. So that's why Professor Rao says a statistician in general, I can claim this as a data practitioner, should be equipped with the practical skills and to choose the appropriate. When we know which technique to be used for what kind of a data, then only that particular outcome will be accurate, precise. If not, the data's outcome is spurious. So we should not create misconceptions. We should not create a misleading environment of choosing the methodology for whatever may be the data. So that's why it clearly notifies us that the job of statistician is not something out of the world. It is applicable in every discipline what you take. Now you take in medical image processing, that image CT scan, MRIs are all used for identifying whether the tumor is of a very serious concentrated one or a benign one. It's a image classification. Now natural language processing, again there are also some advanced statistical methodologies are being used to prepare a proper word cloud, and a concept called sentiment analysis. How many are okay with the statement, how many are not okay with the statement, how many are neutral with the statement. All these things will come there. Like this, there are many wide varieties of techniques applicable in every field of science and engineering, okay, where statistician is there. It's not something out of the world, but something which affects each and every one. Now we are seeing graphs that there is a hike going on, increasing, but where we are observing the peak that will gradually come down with the COVID cases. The curve is indicating to make some notion with our own layman point of view that still the curve is increasing. At a point of time, definitely there will be one point that will come down drastically. Our country will be in a safe hands. So that means the number speaks a lot. The number what we have accumulated from the practical environment will make us to speak in a layman point of view also, will make us to speak in a precise manner. So that's why Charles Hull in American Statistical Association, he says, he says that He says that glory fills the world with loud reports. Loud reports is nothing but when you are able to understand for what kind of a objective, for what kind of a data, you are able to apply the appropriate methodology to beautify the outcomes of the statistical data, then automatically such reports will be louder enough with precise information and accurate information that will make us the glory to the world, because it leads to decision making aspect. Okay, now what actually, because it's focus areas to the graduate budding statisticians who are graduating in different colleges. What he climbed in 1979, see his vision. The gap in making of a statistician is called type 1 error. The gap between statisticians is type 2 error, and interdisciplinary is the type 3 error. In all these three aspects, every data practitioner, every statistician has to shoot their hands. Then only we can have the better trained army of statisticians. Okay, need to produce a statistician with a proper blend of theory and practical knowledge. But at the same time, if I know something, if I'm well versed with classification models, but I'm not to the extent with advanced time series analysis, but I know an expert who is well versed with time series, then we need to exchange ideas so that we can amalgamate the ideas and do some better research for societal development. So this is what it is called type 2 error. This is not happening. The bridging gap between different statisticians who are well equipped with their own knowledge should be connected. Okay, interdisciplinary nature is nothing but subject matter specialists like psychologist, radiologist, okay, pharmacologist, whatever discipline you take, engineering, automobile manufacturing, quality industries, production management, whatever the industry you take, statisticians should step into their shoes so that we can understand the total essence of the experiment to bring out the essence of the data. Okay, so these three are the errors, even I mean errors that are to be recovered, rectified, and to bring back the data into a precise manner. Okay, now we'll, what is a statistical data? What can we do with the statistical data? That's a big question, right? We can do many things. We can do many things. What can we do is that first thing is, I repeat, I stress on this point that first look up the data should be through visualization. Throw the points on XY coordinate, throw the points on 3D axis, throw the points on different four facets of the coordinates. Then data will exhibit some pattern. Okay, here lower coordinates are having lower many samples with the lower y-axis. So visualizing data will allow us to understand the hidden patterns in the data. Thereafter, understanding relations, we can do correlation analysis. Thereafter, we can do model building like regression, logistic regression, lasso regression, and then identifying similar objects like cluster analysis, finite mixture models, and then allocation of objects. It's a pure classification, supervised learning technique. Identifying similar objects is kind of an unsupervised learning technique. Allocation of objects is what we call this discriminant analysis, receiver operating characteristic curves, and then support vector machines, decision trees, random forests. Many techniques are available. And dimensionality reduction is also another important area where we work with the data, and many more are there. Natural language processing, sentiment analysis, text analytics, pattern recognition. Like this, we can do many wide variety of tasks we can do with the data. Okay, so statistics is not just mean, median, mode. Okay, now see, that's what can we do with the data, right? Just for a fast quick action. See, this in x-axis, increasing values of x-axis, decreasing value of y-axis. This is the pattern we have observed. This is what we call negative correlation. Similarly, when we take increasing values of x-axis, there is increasing value of y-axis. But between these two, one important difference we have to notice: the data is little scattered, but the data is little dense here. Okay. Next, there is a curvilinear approach here. There is a straight approach, but majority of the points are concentrated here. So that's what I said, visualizing the data will tell us that how much concentration of the data is lying in the coordinate axis. Basing on that, if I fit a straight line here, will I be able to get the best fit of the model? If I fit a straight line here, how best many points get connected? No, linear fit is not good. So we need a curvilinear approach. Like this, it will make us to take a support that what sort of statistical tool to be chosen after this visualization. So all these things comes under the hub of correlation and regression analysis. Similarly, we have one more graph to go, that here there are green dots are there are blue dots are there, talking about the two characteristics of sociability and outdoor activity of a case study. So here, if you see, higher the sociability activity, more or less outdoor activity is little lower the sociability activity, outdoor activity is little higher. So here, this is one population where we have the cluster, and this is another cluster, but we need to define a mechanism. This red line is what we call the classification rule, the classifier rule, the benchmarking line, which helps us for classification. So this is what we call converting. If we know the labels well in advance, we can have a supervised learning mechanism. If we don't know, then convert the unsupervised data into supervised data by identifying the homogeneous clusters. In general, statistical framework, I was talking about the data, types of data, right? Data is continuous, meeting the normality assumption. This is again big topic that we will take some other time. That if the data is continuous, you have one sample at hand, you have to use one sample t-test. If the data is continuous, again, we restrict this for continuous alone. If there are two samples that were two groups at hand, two populations, single population, more than two populations, okay, then this is the hypothesis what we define. Okay, two sample t-test we have to use. And analog of these two samples is Mann-Whitney here it is Wilcoxon, like here. And if it is discrete data, here it is test for two proportions, here test for one proportion. And if there are more than two populations for discrete data, we use analysis of means. Here, analysis of variance and Kruskal values. Testing, when we do two sample t-test, we test the assumption of equality of variances. There we use F-test. Okay, for this is homogeneity of variance, we use chi-square test, that is NS square by sigma square. And here, several variances we use Bartlett test. This is the total comprehensive framework that when to use which technique for pertaining to the satisfactory information about I have two groups at hand, my data is not normal or not normal, then I have to go with Man-Whitney U test. If the data is rating, I have two population, I should use Man-Whitney. If I have two populations and meeting the continuous and normality assumption, I should use parametric test. Like this, for every objective, the choice do exist, but you should be carefully select that particular technique according to your requirement. Now, another simple checkbox, a kind of a cross tabulation, that if your output variable is continuous, input variable is also continuous, you go with simple regression, correlation, whatever you do. If your output variable is discrete, means hereafter, I mean, here the discrete variable like absence of a disease, presence of a disease, a chronic kidney disease patient, non-disease patient, a long defaulter, non-defaulter, all these things are response variable, but your inputs are more or less continuous and discrete. You can go with logistic regression, support vector machines, so on and so forth. If your input variable is discrete, that is populations you look into, one population, two population, more than two population, but your output variable is continuous, you measure BMI, you measure the velocity of a vehicle, you measure the IQ level, so then you have to go with inferential procedures. But if both X and Y are discrete, that is attribute kind of information, this is what we call chi-square test for independence of attributes. Fine. Another part that is to be focused here is that when we have a certain list of variables, but there will be some sort of a similarity within each variable. To observe the similarity, let us take a view of these words like interesting, professional, trustworthy, experienced, attractive, helpful, reliable, and so on, trained, truthful. If you see here, professional, experienced, skilled, trained, all relates to the proficiency of the employee. They are related to each other. Okay. Now, next one, trustworthy, helpful, reliable, honest, fair. They talk about the nature, the quality what the person has. Okay. And remaining interesting, attractive, entertaining, energetic is talks about the charisma of an individual. This is what we call dimensionality reduction. This is what we call dimensional reduction. The major hub of that is principal component analysis and factor analysis. So why I'm showing all these things is what can we do with data? We can do wonders with the data. Okay, we can chisel the data according to the objective and bring some meaningful thoughts out of it. Now we are into the world of big data, data science, right? Internet of Things. Many new jargons have come, and they are leading in the this science domain. Okay. Now what we do here, from the huge data set, I want to see a filter that how many new users are added into Facebook per minute. So I have to create many filters. New users is one filter, time duration is one filter, and let me have the count. 400 is the count data. Okay. Now users upload 350 million photos every day. Like this, every action of ours in Facebook or any social media generates huge amount of data. See, 22% of the world population is online most of the time. 14.58 million photos per hour. Okay. Like this, 85% of the users watch videos on mute. Okay. Right. So this is how many, because even muting the video is also a data to them. It is telling what? It is describing a fantastic phenomena that how many users, how they are acting, what is their mindset. Totally our mind consciousness is bringing in terms of these figures. Okay. Now there are some more fascinating things which what we say there are 1.5 billion active desktop alone. See the filter here, desktop users, and Facebook, disabled fake accounts, revenue generated, and many users visit Facebook 8 times on an average. Okay, whenever we find time, and most of the time we find for social media, that I agree that most of the time it might increase now because it is in 2019 data. Okay, now we have to think what's so exciting about statistics. Do you really agree that what and all we have seen so far, that we can visualize the data to see the meaningful thoughts out of it, we can build the models, we can choose the appropriate technique to chisel the data to meet our objectives. What not we can do more wonders, not just mean, median, more, but we can do hardcore research while which is involved in discovering methodology, but at the same time, the happiness what we have, the bliss what we have with the data is data speaks more than words. The numbers, the outputs which we represent in report will confidently prove our argument, will confidently prove our argument. So this is what we require, what we get the joy out of statistics. Okay, now, okay, I think I am at the end of the session today. What perceptions on statistical analysis we have? The first thing is, I mean, not first thing, the main point is focus on finding a good solution. To have a proper good solution, you should apply appropriate methodology. Then only it will make you to have to obtain a good solution for which we are paid. There are many consultants outside. Okay, leave with the data. First, we have to understand the data, go along with the data, observe the relation. In correlation analysis, what we have done is increasing x values is increasing y. So we are trying to go along with the data, see the pattern, observe the data, speak what we are observing. So first we have to get accustomed with the data and its attributes. Then only we should go further to the modeling. Just like that, we should not go with the modeling aspect, right? Now search for the model that gives a good solution. Means search for the, here finding a good solution is the focus, but search for the model that gives a solution. What is the good solution stands for? Which is optimal, or whatever the model I got at the first iteration is the final. Okay, so these questions to be addressed. Let us suppose, for instance, we take one simple regression model. I have four predictors, I mean four independent variables on the right hand side, one variable which is continuous type on left hand side. I have built a model that is what we call full model. Full model is nothing but the model which has all the independent variables in the model. Okay. Now, what is that model final? No, not necessarily, because we need to see the importance of each variable which is included for model building. Whether x2 is really contributing to explain y, or x1 is x2 together are contributing to y, or all the three variables are contributing to y. These questions do come to or should come to our mind. To address such kind of a contribution or role of each independent variable, we have to take the support of variable selection procedures. In each and every multiple regression based models like linear regression, logistic regression, discriminant analysis, okay, everywhere we have certain steps to select which which are the variables which contribute more towards explaining my response variable is the task of the model building. Once we have done, is that final? Again, one more question to come, should come. The model which I have obtained after variable selection, is that fine with me to talk about further estimation or prediction of future values? No. Again, we have to validate the model. There comes model validation techniques. That is what we call cross-validation techniques. Okay, cross-validation techniques are a big concept like training, testing data, bootstrapping. Like this, there are wide variety of techniques available to validate your model, that in a general perspective of the confined environment experiment what you have done, your model fits well, that whatever may be the range of the records you have taken for the experiment, still your model is able to obtain this much amount of R square with this much amount of mean square error. Okay, we will speak more and more about the regression modeling when we take the concept of multiple linear regression and simple regression. But now the thing is, predictive accuracy on test sets is the criterion for how good the model is. This is what I have explained for a couple of minutes now that the models are square. The models mean square error. As lower the error, mean square error, the model is that better to explain or to estimate why or to predict why. But to do all these things, Herculean task of these mathematical structures with the statistical logics, we need computer support. Without the computer support, we are nowhere. We cannot meet the requirements of the present huge data scenario. So computers are indispensable partners. Without them, we cannot create the reports with a blink of an eye. With a blink of an eye. So I think I have missed one point. Yeah, along with this, there are wide variety of what we say this non-parametric tests are also there. Here, just I have shown you only three varieties of tests like Wilcoxon, Mann-Whitney, Kruskal values. But apart from that, we have Friedman test, which is analog of repeated measures ANOVA. We have one run test for testing the randomness in the data. And particularly, I wish to add that normality assumption. Normality assumption means whatever the continuous data should have a symmetrical distribution. When it has a symmetrical distribution, that indicates the data has equal amount of data points spreaded from the left of the mean and right of the median. We all know very well that if the data is having bell-shaped curve, its mean, median, and mode will be at the center of the curve, whereas the data points which are spreaded across the left of these three measures will be equal to the right side of the three measures, that is equidistant. Okay, how to verify the normality assumption is the another important area where everyone has to understand. Okay, fine. Now what I do is, with this I stop uh, presenting the thing, and then let us have some discussion. Some more points which I can support you in understanding. Okay, now the floor is for the questions, and later we will end up with what we'll be going to discuss, for the tomorrow's morning session and afternoon session. Okay, now the floor is for all the participants, including organizers, that they can raise questions. Is it fine now? Am I audible? Right, my presentation was clear. Yeah, the question is, do we need to have internet to install the packages? Yes, definitely. Definitely. In order to install the package, you need internet. Okay, but once it is installed into your local library, then no need to have internet. Just like that, you can start working with the libraries what you have installed. Okay, suppose in the morning session we have shown that how to install a package called tree. Okay, install dot packages within double quotation tree, and dependency is equal to true. Once that package is installed, thereafter we can disconnect the internet, but you can call library tree. All the functions, objects, arguments which are available, okay, available will get activated, because now the package is in your R environment. If error has occurred, how to get the prompt? Error regarding, one by one, please, one by one. If error means during installation, who is that? Uh, Meera Joshi. Your question is about if error has occurred. Now, while working, most of the packages, except the graph libraries, okay, except the graph libraries like RGL, rotatable graph libraries, some lattice packages, that requires some sort of internet support. But most of the time, I have not experienced any issues while working with the library once it is installed. Okay, whatever the package is. Fine. Next question is, sir, it is free to us or no need to buy anything? Total packages available, libraries available in R. There is separate library called Datarium. I type here to everyone so that everyone can see the spelling. I request everyone. I request everyone to raise the questions once I complete answering a question which is already in the chat box, so that I can maintain the continuity. Okay. Okay. Yeah. Yeah. Please stop now for raising questions. I request every participants to pause for a while to raise the question, because I have some more questions. There are some more questions to be addressed. Then I'll come to your questions. Okay, right. There is a separate package called Datarium. There is a separate package called Datarium, which has collection of data sets. Okay, fine. So next question is, that's what I said. I have to go a little back now. Can you explain the statistical framework once again briefly? Okay, that is statistical framework. You mean to say that if the data is continuous, more than two populations, you mean to say that, right? Okay. So suppose if we are doing experiment to see the three different levels of three. Is my voice audible? If there is, if you have any problem, then that is the internet connection from your side. Okay. Okay, fine. I got it. I got it. Okay. Where we are now. No video because I have not shared anything. Okay. Okay, where we, I think I lost the, yeah, statistical framework is comes with how many variables you are measuring. Let us take the pH level in 4 different lakes. I want to see whether the pH level is equal in all the 4 different lakes or ponds. Then that 4 will become my population factors: pond 1, pond 2, pond 3, pond 4, or lake 1, lake 2, lake 3, lake 4, and pH levels in each group, in each lake are the sample values. So then when there are more than two, we have to go with ANOVA. Okay, if the data is continuous. I think I'll make it more clear when we deal with inferential statistics from day 3 morning or day 2 afternoon. Okay, right? Okay. Kindly wait for a while. That's what I'm requesting every one of you to wait for a while, so that I can answer the questions which are already posed in the chat box. I will wait for you. I will answer all of your questions. Okay. There is a question called, how can we change raw data in R? I didn't get your question. Raw data means unstructured data or structured data. Okay. That we have to clarify. Okay. And then unstructured data. Unstructured data is nothing but it's based on purely, when coming to the concept of big data scenario or the data set of large size, you can create or you can arrange the data. I mean, not arrange the data, we can work with the same unstructured data just with query based aspect. What and all variables you need to do, you need to work on, take those variables, create filters and get the report done. Okay, that is the answer for that. How can we generate simulated data through R? Okay, there are a variety of random number, I mean, simulation techniques available there, that for simple thing, that simulating a normal distribution. You have R norm, you have R binorm, You have or that like for every distribution, there are some functions available for generating the samples. Okay. Then can we convert the Likert scale data to continuous scale by adding the values? No, it won't be that precise. It won't be that precise because Likert scaling is a distinct values, like strongly agree, disagree, something like that. If you convert that into continuous data, what information I mean, your conversion will not be fruitful for the end reporting aspect. This is my based on my knowledge with experience what I did as educational Shiba Shankar Das. As an educational researcher, how can I complete my entire thesis work by statistical analysis mode? Okay, right. How can I complete my entire thesis work by statistical analysis mode? Sir, it depends upon your study design, study experiment. Okay, and basing on that application of proper analysis using R, you can nicely create, apply all sorts of statistical technique, and then bring out your thesis into very meaningful way. Okay, I think if you are able to speak to me, then I can tell you pertaining to your problem alone. I can tell you what sort of statistical techniques, how you can work with all those techniques. Thank you, sir. Then how can we add variables to data imported to R? We can add variables, but this is a very what we say very minimum usage, because once you import the data, once you have collected only, you will bring the data variables into the framework. Okay, then that's nothing but you have a data frame. There is a called cbind function. Okay, using cbind function, if you have stored the data in VV, let us take R K.B.N, you have to add one more column, one more two or more variables. Then use cbind of data.frame, data.frame of cbind of already available data, and then multiple columns which you wish to add. Then only you can plug the complete new variables into the existing variables. Classification techniques given for better prediction, Python or machine learning. Machine learning, Python is a platform to write the code. Machine learning is nothing but training your data with appropriate models. That is the difference. Okay. How is Vika tool is different from sorry, madam, Harshi, I think so. Vika tool I have not worked on. I'm not in a position to answer this. Okay. Hello, sir. Like FB is collecting our behavioral data. How these information can affect our daily lives and to what extent? Parmeet, oh, you are nice, nice. He's my student, the past student who completed. It is a kind of indication to us to safeguard ourselves, to have a proper to safeguard ourselves, to enlighten ourselves that how to act in a social media, how to disclose the content, what kind of a content to be disclosed into the social media, so that our mindset cannot be read by the other type of group of people who are called as hackers. Okay, recently I came to know, I learned that most of the people, including me, we put in Facebook that I'm traveling from Hyderabad to Delhi via listing, right? But doing that, their bank accounts were hacked. Okay, there are some events happened. So that's why these are all some indications that what to be posted in Facebook, that is our total mind perception to keep ourselves safe. Okay, then how to get a sequence of decimals? By default, R will display 8 to 9 decimals. Okay, you can restrict with round function. What is R language? R is nothing but, I think as of my knowledge goes, R stands for research. Okay, where you can excel. Earlier version of R was S plus, which was purely on C++ background. Even in R, it also works on the background of C++. Okay, then we lost time while practicing as we could not get prompt after error. Okay, madam, can we can discuss? I want to see what actually the problem is. Okay, sir, feedback link that is to be asked to the how organizers, how we know which method is suitable on any data set. Okay, I will take this in very detailed way when we start inferential statistics. Okay, right? How to import the data from Excel to our console? This is simple. Read.xls, or you can store the data in CSV format, read.csv, or you can directly use the path of your folder where the data set is saved, of which format. Read, suppose if the set is Excel, then read.xls with that path and some arguments which are relevant to import the data. So that is there. Okay. We can import data from Excel by using read. That's good. Thank you. Thank you, uh, Vignay. Vignya. What is the difference between our language and our studio? Our language, see, our language is in our studio also. We use the languages which are inbuilt in R. So you should tell that whatever morning we have seen some slides there. Oh my God, 33 messages. Are you answering or are raising questions? If there are some more questions, kindly wait. Let me complete. Okay. Where we are now. Yeah, difference between our studio is a composite thing where you have our console as a part of our studio. Okay, and then there will be a script that what and all we can write. First we can write and correct it and then execute it. There will be a view plots, how to install a packages, what are the packages installed. That is one button. I'll show you tomorrow. Okay, and then there will be environment, what and all data sets loaded into R, we can see there. Okay, that is what we call our studio. Our language is different. Our language means whatever the codings you have entertained. That is what. Okay, can you explain practically sentiment analysis, behavior analysis with some example taking? Yeah, definitely. I'll try to do that, sir. I'll try to do that basing on the time availability. Good concept. Please compare SPSS and R. Okay. See, coming to the usual traditional aspect, to some extent, SPSS is preferable. And R has a lot of advantages, particularly with machine learning and data visualization. Whereas SPSS, that is my observations with whatever the practice I do with both SPSS and R, both are equally good, but particularly data visualization is at the most best in R. There are good variety of packages available in R for data visualization, but here it is a ready mechanism. Another thing is who are lovers of programming, better they can choose R, uh, whereas who have knowledge about what we say this statistical methods, how to apply, then go with a menu-driven option using SPSS. Thank you, thank you, thank you. There are some appraisals also. Thanks for those good words about the explanation. Sir, how can we have live examples where all the post-hoc tests are used widely? I will come to that, madam. When I handle the ANOVA, I'm using Bonferroni and Taki test. So Bonferroni test, how we can understand what is the relevance of post-hoc test, that and all I will be tackling there. Okay. Okay, then does feedback link. Okay. Oh, thank you, madam. You resolved it, then that's fine. What is the most appropriate way of dealing missing values of an ordinary? Okay. Ordinal variable. Ordinal variables means you will be having strongly agree, disagree. So there is a package called mice, I think so. Mice or some other packages are available in R, which talks about how to restore the values if the data is of ordinal type. Most of the time it will replace by median. Okay, or even replacing median with the different conditions are there, that what conditions is, just let me recollect. Yeah, different basing on nearest neighborhood of the values, or the total data set, or taking only the portion where the data set, where the NAs are prevailing. Okay. Okay, madam. So Amyajit Nandi is asking about sentiment analysis in later session. I'll try to do that maybe after completing the total contents what we have planned for this program. Yes, I do share. I do share the PPT. How to handle the data which is labeled in SPSS. You can directly import the labeled data of SPSS into R. Okay, there is an argument called read.spss. Automatically, the data gets imported. SPSS data get imported into the R. Okay. Okay, then, sir, is packages are downloadable, download compulsory, or by online we may use the packages? Better it is to be, better it get downloaded, because it will be useful for further research. Suppose if you have a, my best suggestion is to download it permanently. Even after upgradation of your R, the packages will remain safe in your R environment of your desktop or laptop. If you don't have internet connectivity in future aspects, then that will create an issue while programming for further thing. If I want to publish the paper, use some statistical, shall I download the data from website and publish? And can you please tell me website for free? Okay, there are openly available data sets. Okay, machine learning repository is there, Kaggle is there. Like this, I think there are some other websites which where openly available data sets are there, where you can make use of them, apply some statistical models, do a case study presentation, submit them. For if journal is okay with that, then you can submit it. And the other thing is, but you have to cite from where. That is very, very important thing. That's a copyright thing, that you have to cite the donor of the data from, or the website where you have, from where the data you have taken. Okay. Thank you. The name of the R is a partly based on the first names of the first two R authors. Okay. Thank you, madam. Robert Gentleman and Ross Ishaka. Yeah. Okay. R is the best for visualization. Then what is the difference between Python and R? Okay. Python. Okay. What is the difference? Python and R means both can do wonders. Okay. Earlier question was with SPSS and R. Now the question is with Python and R. It depends. I mean, like machine learning tools, NLPs, all these things can be handled very easily with Scikit, Matplotlib, and some other tools libraries available in Python. And still, you can do better visualization even with Python as you do with R. Okay. Okay, then, okay, I do go slow. Okay, this is the common comment I get. I will share the PPT. Yeah, coding, that and all, I will tell you. In next sessions, I'll start telling you how to create a for loop, how to create all these things if, I mean, if time permits. But coding can be done using available exist built-in functions that I'll show you. How to create some different kinds of a 3D data visualization. Okay. Word to R, I don't think so, but it should be, at least it should be in that file or text file. Okay, thank you. Which is the best analysis software in medical field? Okay, I'm more fascinated towards R. I say R, but apart from that, for essential, techniques like survival, ROC curves, sample size determination, you can go with MedCalc, you can go with IPinfo, or R also will do the task. Why I prefer R is you have multiple options. You can bind all the R coding, all built-in functions to get a beautiful information. That's what, whereas this IPinfo MedCalc is whatever existing in that particular package, you have to get it. It's like a fast food. But R is like you can create your delicious food by your hands. Okay, by adding all ingredients what you require and create a nice beautiful report out of your data. Okay, right. Any more questions? I think I have covered almost all questions. Still, if there are any questions, then I'm ready to answer them. If organizers permit me for 5 minutes more, I'll be able to address the questions. Thank you. Okay, thanks for your appreciations and your open views. If there are any critical comments, please do tell so that we can rectify in next later sessions. But I'll keep in mind that I'll try to work on with sentiment analysis if possible, based on the time permit of the schedule. Okay, right. Vijay, I think, what is the user